Hello and welcome to this lesson on data storage in Android. In this lesson we will cover data storage options in Android and take a closer look at file storage. There are many reasons why an application may require a data storage component implemented. One of the most common is to keep data persistent between application sessions. If we simply store a data object in the memory as a member of an activity or another application component, then when the application is destroyed and restarted, we will lose that information. For instance, the user's progress through the application, like keeping track of how many levels of a game a user has completed, is an important aspect to retain between application sessions. One of the most common components of Android applications is a settings or preferences screen that allows the user to configure behavior or other aspects of the application. Although this information can be stored in many different ways on the device or on the cloud, it is very important that it is retained in some way between application sessions. Sometimes it is crucial to know the application history, for instance in a browser application, what pages were previously visited by the user. For more complex applications, there may be a requirement to compile, configure, or calculate large datasets. In many cases, the size of these datasets may be prohibitive to store them completely in memory while the application is running. In cases like this, chunks of data can be stored to conserve on memory usage. This can be particularly important when dealing with large amounts of images. Even when we are storing information in the memory, it may be cumbersome to pass this information between different activities, services, or threads of the same application. And an elegant solution may be to save this data on the device so that components can easily access it from a central data store. Today, many applications draw some or most of their data through network services. Network calls can be costly in light of the application speed and user interaction. So caching information like images on the disk so that they do not constantly have to download from remote resources will allow quicker and more efficient timing in applications. When storing data in the Android environment, there are several options, with each option having its own advantages and disadvantages. Storing information on internal storage will save the private data to the device's internal storage memory. For some devices and configurations, this option also exists to store information on a mounted external storage component like an SD card. Note that data stored in external storage will be public to the user and other applications. Since there is often a need to have simple key-value pairs in applications, like getting setting preferences or user information, in Android we have the Shared Preferences component, which allows to store private primitive data in key-value pairs. When in need of more extensive data, we can utilize a private SQL database for storing our structured data. In other cases, we can also use a network connection to store our data on cloud or network-based services. The internal storage of the Android device offers advantages to storing file-based chunks of data. It's always available and can't be unmounted like external storage. Files saved here are accessible only by your application by default, and hidden from other applications and the user, although rooting and other configuration changes of the device can allow to reveal this data. This information is saved in the private application data space, so when the user uninstalls your application, the system removes all your application's files from internal storage. Internal storage is best when you want to be sure that neither the user nor other apps can access your files. One of the pre-configured aspects of the internal storage is a cache directory. Cache is an important tool for storing temporary files in the device. This data might consist of common network results like JSON data, images, or even full HTTP responses. We will cover network operations and JSONs more in future lessons. This data can then be accessed later or easily cleared by the user or the application when the cache becomes full. Other temporary files like edited but unsaved documents, or files or session information of the current application sessions, are also good candidates for storage in the device cache. The cache can easily be accessed from the application by calling on the application context the method getCacheDir, which will return a file object that points to the absolute path to the application-specific cache directory. Each application that is installed is given its own internal storage directory that is protected from other applications and users by default. These files and other components are contained within an Android application sandbox, which isolates your app data and code execution from other apps. By default, files that you create on internal storage are accessible only to your application. This protection is implemented by Android and is sufficient for most applications. To provide additional protection for sensitive data, you might choose to encrypt local files using a key that is not directly accessible to the application. For example, a key can be placed in a key store and protected with a user password that is not stored on the device. While this does not protect data from a root compromise that can monitor the user inputting the password, it can provide protection for a lost device without file system encryption. Users can also see some information about the application data stored in the protected application file system. On the Android device, a user can open the app info for a given application and see how much total internal storage the application takes up, how much of that storage is used by the application itself, and how much of the storage is used by the data the application has saved. In addition, the user can see how much storage the application is currently using in its cache storage. Android also gives the user the ability to clear some of this data, which is important to note when using internal storage for data storage or for caching. By pressing the Clear Data button, the user will clear all of the application data stored in the application protected file system. In addition, the user can clear the cache of the application by clicking the Clear Cache button. When running an application on Android emulator, we'll have better access to several components of the virtual device, including more access to the application's private file directory. If we open the Android device monitor from Android Studio, we can see the file system through the File Explorer view. As we can see here in this image, in the File Explorer, we can view file directories for the com.android.dialer application. We see in the file directory there is a cache folder, a database folder, and some saved shared preferences. These files can be downloaded from the virtual device and uploaded with changes by using the Pull a file from device and Push a file onto the device buttons in the top right corner of the view. In some cases, we might desire to save files or information outside of the protected application file system. In those cases, we can store information on an external storage device when it is accessible to the Android system. These files and data are globally readable and writable, although encryption can be used to obfuscate the information. This can allow for easily sharing information or files among different applications by storing them in a public space. Since the external storage is globally readable and writable, it must be taken into account that the files can be deleted or changed by users or other applications. In contrast to the files stored within the application file directory, the files saved to external storage will not be removed when the application is uninstalled. When utilizing file storage, specific permissions may be required in order to access the reading and writing capabilities. In the case of internal storage, no extra permissions are required to read or write files to the application file directory. In the case of external storage, the write external storage must be declared in the Android manifest in order to write files to the external file system. In the case of read-only access, the permission read external storage can be added to the Android manifest. Starting at API level 19, these permissions are not required to read or write files in your application-specific directories that are returned by calls to the methods getExternalFilesDir and getExternalCacheDir. In this demo application, we will allow the user to create files within the application private file storage. First, let's take a look at the Android manifest for this application. We notice that we have one activity declared, our main activity, and no special permissions declared. No special permissions are required since we're going to save to our internal application storage. Now let's take a look at the XML layout for our main activity for this application. The UI for this application, as we see here, has an edit text for entering the file name at the top. Below the file name edit text are two buttons, one for save and one for read, and finally a large text view surrounded with a teal background. This application will allow the user to create a file with the name entered in the file name edit text by pressing the save button, and display the contents of a file in the teal text view area by pressing the read button. These two buttons have a method callback onClick set to their onClick callbacks in our main activity, so let's take a look at that method now. In our onClick callback, we first grab the text view from our edit text, which we have referenced in our mFileName object, and ensure that the file name is not empty. If the file name is empty, then we show a toast informing that a file name is required. Then we differentiate which button was pressed based upon the view ID. For the save button, we call the method save to file, and for the read button, we call the method readFromFile, with the context and string for the file name. Let's look at the SaveToFile method now. In the SaveToFile method, we open an output file stream to our private application directory by calling openFileOutput with the file name as a string. We then receive back a file output stream to the file of the requested name, which will be created if it does not already exist. We can then write to the file by calling the write method on the file output stream and passing it the bytes of our file name string. We have declared a constant numCopies. This allows us to write to the file name numCopies amount of times the string of the file name. We then, most importantly, close the file output stream to ensure a correct writing to the file. Also note that the method openFileOutput can throw the exception file not found, and we will catch that error in our try and catch statement and print a stack trace of the exception in the case that one is thrown. Now let's take a look at how we read the content from a file in our readFromFile method. In the readFromFile method, we open a file input stream with a call to openFileInput, which similarly can throw a file not found exception, so we surround it in a try and catch statement. Once we obtain the stream, we can read each byte of the stream by calling the read method, which returns the byte of the character or a -1 in the case we have reached the end of the stream. We add the bytes to a string builder. The string builder will allow us to easily compile a string byte by byte. Once the file is read, we post the compiled string to the file content text view. Now let's run the application in our emulator. Here in our application, we can enter a file name for saving to our local file system, and then press the Save button and it will be saved to our application file system. Then when we press the Read button, we see the file name written 10 times in the way that we have devised it in the code. Thank you for joining us in this lesson on file storage. Join us in our next lesson where we'll take a look at the Shared Preferences feature in Android.